So I've shown you how for the hexagonal close packed structure, the basal slip, it's not possible to twin on the basal plane when you have a basal plane shear. However, non-basal planes, in this case the 1/1 plane, it is possible to shear on each successive plane in the same direction. So I've got a model here of the 1/1 plane, the pyramidal plane, the first pyramidal plane, and normally the slip that people would normally be familiar with for the pyramidal plane is C+A slip, and that involves three partials, 1, 2, 3, and that then brings my crystal back into register, 1, 2, 3. So I have my basal plane here, and my crystal is, the basal plane is parallel with the tabletop here. What happens if I try and twin? So I just showed you that the slip operation that involves three partials. Now if I just think about the first partial and move the first one of the planes up by that first partial, I can move the next plane up also by the same partial in the same direction. And what that does is that I bring the basal plane into a different orientation. So what we have here is, if my start off with my basal plane horizontal, and now I apply a twin operation, my basal plane is now at a different angle, which is approximately 57 degrees rotation of the basal plane. And that's the twinning operation. The point to note, though, is in a hexagonal crystal, unlike the FCC, in FCC, that kind of shear would bring you back into register. All the atoms are nicely aligned. In the hexagonal, other than the one undistorted plane, which is the basal plane, the rest of the planes are out of alignment, and that's what's called. And then they can reform. The crystal will reform around the basal plane in a different orientation by shuffling. That's what's called a shuffle. They'll each move a little bit and shuffle within one another, within the structure, in order to maintain that shear operation. So we want to have the shear because we have an applied stress, but we keep with this one undistorted plane, and the rest of the crystal then conforms with that basal plane and reforms, if you like, shuffles to create the undistorted HCP structure.